Okay, so I'm going to go over the notes from today, October 3rd. We studied about periodic trends. We are learning about atomic radii, electronegativity, ionization energy, shielding, and ionic radii. So my expectations are for you to know the definition, the group trend, the period trend, and the summary, what they look like, what is the largest one, what is the smallest one on the periodic table. So if I go too fast, please make sure you pause the video so that way you can catch up at your leisure. Okay, so let's start with the definition of atomic radii. This is the size of the atom. This is from the nucleus of one atom to the nucleus of the next atom. The group trend, remember a group is the columns, the group or family. The energy levels increase and the outer electrons are further away, making the atom larger. So this makes sense. So we can see that our group trend increases as we go down. So as we go across the period, remember we end a sentence with period, so as we go across, the electrons are being added to the same energy level. The attraction between the nucleus here and the electrons increases, pulling that atom tighter and closer together. So we're going to decrease as we go across the periodic table, and we increase as we go down. So our general trend is on this diagonal. Remember, francium is going to have the largest atomic radius, and helium will have the smallest. Okay, I'm using blue for decrease and red for increase. Okay, so the next trend, again, hit pause if I go too fast. The next trend that you need to know is electronegativity. This is one of the most important concepts for chemical bonding, especially with the ionic bonding that we have in sophomore chemistry. This is the tendency for atoms to attract electrons. Now, as we go down the columns, the more energy levels between the nucleus, we call that shielding, the outer level makes it harder to attract electrons from other atoms. So as we go down the columns, our electronegativity is going to decrease. That's that tendency for atoms in that nucleus to attract electrons. Or I'm sorry, the protons to attract those electrons from other atoms. As we go across the period, though, it's going to increase because nonmetals want to gain electrons. Therefore, they have a greater tendency to attract electrons. Remember to stop at the halogens. We're going to go ahead and add a little and cross out our noble gases. Okay, because fluorine is the most electronegative element. It has just two energy levels, and it just needs one more electron to have that full outer shell. So, and francium has 7 energy levels and has 1 electron in its outer shell, and it wants to get rid of it, so it will have the lowest electronegativity. Ionization energy, this is the energy required to remove an electron. We're going to have that same trend that we had for electronegativity, but it's for different reasons, of course. So ionization energy, the energy required to remove an electron. This is going to decrease as we go down because the outermost electron furthest from the nucleus makes it easier to remove that electron. And as we go across, remember the nuclear charge is increasing, and the attraction between the nucleus and the electrons is increasing, making it harder to remove an electron. The nucleus and electrons are being pulled closer together. So helium will have the highest ionization energy. It has just one energy level, and it has a full energy level. So you're not going to remove an electron from helium. Okay, and of course, francium having those 7 energy levels and that 1 extra electron, it's going to have the lowest ionization energy. It wants to get rid of 1. Okay, again, if I'm going too fast, please pause it at your leisure. I have to keep these under 10 minutes. and we're going to practice as well. Okay, shielding. This is the number of energy levels between the nucleus and the outer valence electrons. All right, so it's going to increase as we go down because the energy levels increase. You can think of shielding as kind of going to a dance with someone. You know, if you go in a big crowd, that crowd is going to shield you from, you know, maybe finding another dance partner. Now, as we go across the periods, the energy levels stay the same, so we have no change in shielding. So that's what this trend looks like. Okay, so before we get to ionic radius, let's go ahead and practice a few. So we said that francium has the highest atomic radius and helium has the smallest. So if I was to ask you, what has the higher atomic radius? Would that be strontium or magnesium? Of course, you would tell me strontium because it's closer to francium. If I asked you silicon or sulfur, again, you would tell me silicon because it's closer to francium or it's furthest from helium. All right? Electronegativity. So electronegativity, the tendency to attract an electron. We said that fluorine is the most electronegative. So if I asked you which element has the higher electronegativity, and I asked you sulfur or phosphorus, you would tell me sulfur because it's closer to fluorine. Okay? If I was to ask you aluminum or arsenic, what would you say? You would have to say aluminum because it's up one energy level. Okay. Now, what if I asked you neon or gallium? Of course, it would not be neon because this is a noble gas, and noble gases have zero electronegativity. Ionization energy. Ionization energy, the energy required to remove an electron. Helium would have the highest ionization energy. So if I asked you which element has the higher ionization energy, would that be aluminum or carbon? Of course, you would tell me carbon. Okay. Please ask if you have any questions over that. Okay. Let's wrap this up with ionic radius. This is going to be the size of the atom that has gained or lost electrons. Remember, cations have a positive charge. Remember, cat are positive. Cations. They have lost electrons. The cation will be smaller than their atoms because they've lost an electron. Remember, atoms are neutral or have no charge. This is because the nuclear charge on the atom and the ion is the same. They have the same number of protons. An atom will gain or lose electron, so the ion has fewer electrons, therefore the nucleus pulls those electrons closer. Okay, so let's look at the summary. You can see the lithium atom is larger than the lithium ion. Again, because that positive nucleus is able to pull in those electrons, outer electrons, closer. Anions. Anions have a negative charge. They have gained electrons. Anions will be larger than their atoms. Remember, atoms are neutral or have no charge. Remember again the nuclear charge on the atom and the ion is the same. They're both positive. They have the same number of protons. The atom is going to gain or lose electrons. In this case, it's going to gain electrons. So the ion has more electrons than the atom. So the nucleus cannot pull the electrons closer. It can only pull fewer electrons closer. So looking at here at group 5A, you can see the atom is smaller than the anion for nitrogen that has gained 3 electrons. Okay, same thing with this chlorine. The atom is going to be smaller than the anion that has gained an electron. Okay? Please make sure that you study and ask me any questions.